So the other good news is that when you're doing a problem, everything works almost exactly the same. So let's work through a problem. Let's see how it goes almost exactly the same. How many M&Ms in a bag? There's supposed to be 1,000 M&Ms in a bag, but I claim it's more than that. So you take a sample of 80 bags, and from that you get X bar is 1036, and you don't have sigma, but from your sample you get S equals 97.3. So what's the first thing that we do? Write down HO, H1. So what is it? What's the claim? Okay, HO is not 1,000. HO is a statement. What's the statement? So for HO you get mu equals 1,000, and what about for H1? Mu is greater than 1,000. Alright, so now we need to write down our things. So first we write down mu x bar. Now what is mu x bar? That's 1,000. Now, can we write down sigma x bar? There's no sigma, we can't have sigma x bar. So guess instead of sigma x bar, what do we have? S x bar. Now how do you think we find S of x bar? S divided by the square root of n. So it works, it's almost the same, just a little bit different. So in this case we get 97.3 divided by the square root of 80. So let's work out what that equals. 97.3 divided by the square root of 80, 10.8785. And what's the next thing we need to ask? Is the distribution normal? So is this distribution normal? Is this distribution normal? No. Why is it not normal? We don't have sigma. We don't have sigma, all bets are off. What distribution are we going to use? We're going to use the t distribution, just like we were just talking about. So is this normal? No. We don't have sigma. We have S. So we're going to use t distribution. So now we're going to draw the picture, but like I said, the picture for t looks almost the same as the picture for S. So you just pretty much draw the same picture. So now how do we label this? 0 goes in the middle, but not for z. 0 goes in the middle for what? For t. So label that with t. Let me put a box around that. That's different. Okay. So what else do we have? 1,000 goes in the middle for what? X bar is still an X. We're still talking about X bars. It's still an X bar value. Okay. Now what else do we mark off? 1,036. And then we shade to the right because it's greater than. So now what do we have to find? We don't find a z-score, we find a t-score. Well, guess what the formula for t is? It's basically exactly the same. So to find the t, exactly. So we use our value minus x bar minus mu x bar divided by, before we had sigma x bar, now we're going to use sx bar. This is not so bad. So x bar was 1036, mu x bar was 1,000, and s x bar was 10.8785. So now we just have to work that out. So this equals 36 divided by 10.8785. So that gives us a t score of 3.3093. So let's fill that in on the picture. Now what do we have to do? Now we have to find the area. I'll use st.disk. So what do? Analysis, distribution, and which distribution are we using? The t distribution. So what do I have to fill in? Okay. So the t value was 3.3093, and now have to change the degrees of freedom. Don't forget that. That's important. That is a difference compared to the z-score normal distribution. So what's the degrees of freedom here? Well, how do we figure out the degrees of freedom? Let's flip back to it so we remember that. Degrees of freedom is just n minus 1. Exactly. So this is important. Let's actually write this down in this problem. So in addition to all these things, we need to write down degrees of freedom, which I'm going to call df. So what is df? It's n minus 1, which is 80 minus 1. That's 79. So degrees of freedom is 79. Now we're ready. Click evaluate, and it tells me what I need. The area to the right is 0.0007. Area to the left is 0.9993. So now we're ready to make our conclusion. What's our conclusion? We are 0.9993 confident that mu is greater than 1,000. Now say it in English. That, how do you say mu greater than 1,000 in English in this problem? There are more than 1,000 M&Ms in a bag on average. And what's your p-value? 0.0007. And as Benny said, we say we reject HO, accept H1 with 0.9993 confidence. So a couple of quick comments. In Excel, if you use Excel and the t distribution, it only takes positive t values. If you try to put in a negative t value, it'll give you an error. So just be aware of that. For Excel, st.disk is fine. Next, when you calculate your t or z value, that is called the test statistic. That's just terminology. Okay. And really quickly, what I have in the notes here is a comparison between normal distribution and t distribution. As we just saw, everything is basically the same, but a little bit different. So this chart represents a summary of all those things. I'm sorry? The t or z value is called the test statistic. And one other bit of notation, that thing that's called the significance, mathematicians like to put in a little Greek letter for that. It's called alpha. So it's a funny looking X, or some people say it looks like a fish, whatever. That's called alpha. And one final comment, the way that the textbook covers this subject. So I mentioned already a couple times that there are several different ways you can write down your conclusion. These all come from the fact that over the years there were several different approaches to how do you solve this problem. I have taught you one approach. I have taught you the approach that I think is the clearest and best approach. The textbook does, I think, all the approaches, so they will sometimes ask questions in a slightly weird way that have to do with the approaches that they use. If you see something like, what is the, anytime you see the phrase critical value, skip it. Don't even ask me, I don't understand this, what does this mean, because I'm not going to explain it to you. I have tried, it becomes very confusing. Anytime you see critical value, skip it. Use this method and you'll be able to answer all the questions. Okay, thank you, get out of here. So we've now done up through 10.3. So you can work on that.